Good morning, students. See, in last class, we discussed about P block elements and we are completed P block elements. I think all of you are wrote notes also. And today we shall begin with a physical chemistry first topic, which is nothing but solid state. See, matter exists in three important physical states. Those are solid, liquid and gaseous state. In a solid state, the particles are closely arranged. So, solids have definite shape, size and volume. If you go for liquid, the particles are loosely held. They are not tightly as in solid state. If you go for gaseous state, the particles are far away from each other. So therefore, solid, liquid and gaseous state, they have difference in their physical state due to the arrangement of particles. So, basic concept of solid state, liquid state and gaseous state you studied in first P. According to your second PC syllabus, we have to concentrate on solid state. How these solid state particles are arranged each other, what are the geometries shown by solid state particles, what is unit cell, what are the different types of solids, what are the defects in solids. We have to study again packing efficiency and density of a solid calculation, and we have to study magnetic property of a solid. So that comprises your syllabus, nearly 6 to 7 or syllabus you are going to study. So today we shall begin with some of the introduction about solid and different types of solid. Are you clear? Okay. See, in solids, the particles are held close to each other. They are having a strong electrostatic force of attraction, which is nothing but Coulombic force. And those solid particles, they are arranged in a regular pattern. So the voids or the gap is very less. And therefore, these solids have definite shape, size and volume. See, as you go for the particles, assume those all the particles are spherical in shape. They are well arranged. Proper shape you can get due to the arrangement of the particles. And that arrangement is somewhat different in different types of solids. See, as it is a solid state, it cannot be compressed, it is rigid. And particles, intermolecular particles, with a short distance, very short distance, they can oscillate their mean position, they can vibrate in their mean position, they cannot flow. Are you clear? So, what are the basic characteristics of solid? The basic characteristics of solids are, solids have definite shape, size and volume. Intermolecular particle distance are very short. Particles are closely arranged. These particles, either it may be an atom or molecule, they can move, they can vibrate, there is no momentum. They can oscillate in their mean position, and they are incompressible and rigid. Why they are rigid? Due to the arrangement of the particle. Are you clear? So solids are entirely different from other physical states. See, if you compare liquids and gases, we will call them as they are the particles can flow. You cannot compare that to a solid state. In solid state, particles are well arranged. See, in gaseous and in liquid state, the particles can float, they can move. We can't find a rigidity. Okay, that is nothing but the basic characteristics of solid state. What are the important characteristics of solid state? They have definite shape, size, and volume. The intermolecular particles having short distance, and the particles are held together with a strong force. And solid state particles, that means solids cannot be compressed, they are rigid. Okay, these are the general characteristics of solid state. So you will get in those. Okay, I will repeat again. So solids have definite shape, size, and volume. Are you clear? In simple analogy, you studied this. Slowly we will level. We can easily understand the concept. They are rigid. They are rigid as particle due to the particle arrangement. See, the distance between the particles is very less, which is negligible. Whatever the intermolecular attraction, particle attraction, they are very close. So they have definite shape. So simple question, 2-mark question you can ask. What are the characteristics of solids? You have to write. Okay. Then solids can be broadly classified into two types. One is crystalline solid, and another one is amorphous solid. Are you clear? Crystalline solids and amorphous solids. Solids are broadly classified into crystalline solids and amorphous solids. So, what do you mean by crystalline solid? In crystalline solids, the particles are arranged. In a long range order. In amorphous solid, the particles are arranged in short range order. No doubt both are solids. So we shall discuss some points about crystalline solids. In crystalline solids, the particles are arranged. The particles are arranged in long range order. Are you clear? See, as these are the particles of a solid. See, again you can find smaller particles like a regular arrangement, and even gives a definite shape. So the solids have definite shape due to a long range order. Are you clear? So, in crystalline solid, we can find a long range order. All the particles are orderly arranged to a long range. If you go for its melting point, so it has a sharp melting point. See, by increasing the temperature, solid start to melt, and it changes physical state at a particular point of temperature. Are you clear? So they have sharp melting point. Are you clear? These crystalline solids. See, solids are stable at low temperature. No doubt about it. As we increase the temperature, then it starts to melt, may change its physical state. The particle arrangement can be broken. So at that time, it's a one physical state, solid state, it changes to liquid, or in some other state at a sharp temperature, sharp melting point. So therefore, crystalline solids have sharp melting point. Are you clear? Understood? They have a long range order arrangement and they have sharp melting point. If you go for other characteristics of crystalline solid, they have sharp melting point. They have sharp melting point. See, next part in crystalline solid. If you go for its cleavage, when you cut by a knife, it can cleave. See, it can cleave in a clean surface. A clean cut is possible. A clean cut, very clear surface, smooth surface we can find. So that is nothing but a cleavage property. It can cleave with a smooth surface. Are you clear? So that is nothing but cleavage. If you just cut by a knife, it can be easily cut. And so the surface is very well observed. You can find. So that is nothing but the cleavage property of a crystalline solid. Okay, if you go for next part of a crystalline solid, see in crystalline solid, as it has cleaved and by cutted by a knife, it gives a sharp surface. So these are the basic characteristics of a crystalline solid. What is that? So it has a long range order, its melting point is sharp and cleavage property. It cannot, on cutting, it cannot break as we like. Rough surface we can't find. Very smooth surface we can find. Okay, these are the basic three important points you have to remember. Just compare with the amorphous. See, in amorphous solid, we have no doubt it is a solid, an orderly arrangement is there. Even that order arrangement is for a short range. For a short range, you can find its arrangement. So therefore, they are called amorphous solid. The particles are arranged in orderly to a short range. That is the major difference between a crystalline solid and an amorphous solid. If you go for its melting point, it has a range of melting point. By increasing the temperature, amorphous solids start to melt over a range of temperature, 5 to 10 or more than 10. It changes its physical state. That is called, it has a range of melting point. And it has what? Short range order. The particles are short range order. If you go for cleavage property, so it can break without a smooth surface. A rough surface we can observe. But when an amorphous solid can be cut by a knife, we will get a rough surface, which cannot be compared as smooth as in crystalline solid. Are you clear? Okay. So we have a rough surface and they are non-directional. So another important property of these crystalline amorphous you have to compare is anisotropic. See, crystalline solids are anisotropic in nature. Anisotropic in nature. See, crystalline solid, the physical characteristics like refractive index. See, anisotropic due to its long range order. So we can find the particles. See, as this is one of the particles, again another layer, so another. We can find it anyway like this. See, similar particles cannot be arranged with so therefore, this is called anisotropic in nature. Their refractive index may be different. Are you clear? So that is called anisotropy. But amorphous solids are isotropic in nature. Just opposite of that, isotropic. Isotropic in nature. So refractive index of these amorphous solid is the same in any direction. In any direction. But here, if you go for different direction, then refractive index is changing due to long range order. Long range order. Very important concept. You have to remember they are anisotropic and these are isotropic in nature. Are you clear? Okay. See, by knowing the characteristics of solid state and types of solids, those are crystalline solid and amorphous solid. So, what are crystalline solid? In solids, if the particles are arranged a long range order, arrangement of particle in a long range order, they are said to be crystalline solid. Crystalline solid have sharp melting point. As we increase the temperature, they melt at a particular temperature. And cleavage property, go for cleavage property. When these crystalline solid are cut, it gives a sharp cut. Are you clear? There is no rough surface. And they are anisotropic. Some of the even electrical, anything we can find. See, they are anisotropic in nature. Due to the arrangement of particles, if you go for different direction, their physical property. So, a similar particles arrangement is there. It may give difference in the physical properties like the refractive index. Such is called, that is called anisotropic. Repeatedly, I am going to tell what do you mean by anisotropy. See, amorphous solids are isotropic in nature. Crystalline solids are anisotropic in nature. See, if you understood what is anisotropy and what is isotropy, then only you can understand easily. Are you clear? Okay. So every year, we will ask, differentiate between amorphous solid and crystalline solid. Can you make a difference? Easily you can find. What are the characteristics of crystalline solid? What are the characteristics of amorphous solid? Easily you can write. See, as the particles we should study in detail the difference between. If it is asked for 2 marks, you have to answer. Only 2 points. Particularly, we will ask some questions. Differentiate crystalline and amorphous solid due to their arrangement of particle and melting point. So you have to write particularly that point only. As we ask only the difference of particular arrangement and as well as melting point. So crystalline solids have long range order and amorphous solids have short range. If you go for again melting point, they have sharp melting point, and these amorphous solids have range of melting point. That is the difference. They will melt at a range of temperature. Whatever difference of 5 to 10 degrees centigrade. Okay, I will repeat again. See, as it is anisotropic, the physical property like refractive index is different in crystalline solid and it is same in amorphous solid. Therefore, they are called isotropic in nature. Are you clear? These are the basic difference between the crystalline solid and amorphous solid. Even you can easily understand the characteristic also. So, what are the examples for crystalline solid? See, all metals, copper, magnesium, sodium chloride, ionic solids. So, all these are examples for crystalline solid. So, amorphous solid examples: glass, plastic, fibers are amorphous solid. So, important one we have to remember the example. So, KCl, even copper metal, If you go for amorphous solid, see glass, and again fibers. All these are amorphous solid. Another basic thing we have to remember about crystalline amorphous solid. So these are true solids. These are true solids. And these are pseudo solid, which is also called supercooled liquids. They are also called supercooled liquids. Are you clear? Okay, dear students, you studied what are the difference between crystalline solid and amorphous solid. Very slowly, I told you. See, these crystalline solids are also called true solids, and these amorphous solids are called pseudo solids. They are also called supercooled liquids. Are you clear? See, take for example glass. We can observe the glass on old buildings, from historical buildings. The bottom portion of the glass is somewhat thick. So it is nothing but a supercooled liquid due to temperature. The glass melts and it settles at the bottom side. We can experience it. Okay, therefore, these amorphous solids are also called what? Pseudo solids. So, point by point you observe. You have to familiar to write the difference between crystalline solid and amorphous solid. Repeatedly I am going to tell you. You may get bored. But my intention is all the students you have to understand very clearly. Are you clear? Okay. What are the difference between crystalline solid and amorphous solid? So crystalline solids have particle arrangement to a long range order, and in amorphous solid the particles are arranged in a short range order. They have sharp melting point, they have range of melting point. They can cleave with a clean surface and they cannot cleave with a clean surface, with a rough surface. They are called true solids, and amorphous solids are also called pseudo solids or supercooled liquids. Okay, these are the basic difference between the crystalline solid and amorphous solid. Are you clear? Okay, we shall continue our discussion on different types of crystalline solid. What are the different types of crystalline solid? So different types of crystalline solids are they are classified into four important types. Those crystalline solids are say one is ionic solid, that is, or we will go by molecular solid. Different types of crystalline solid. First one is molecular solid, and next one is ionic solids, and next one is metallic solids, and next one is covalent solids, or which is also called network solids. Are you clear? What are the four important types of crystalline solid? Molecular solid, ionic solid, metallic solid, and covalent solid. Are you clear? So we shall study one by one. Crystalline solids are classified into four types. Those are molecular solid, ionic solid, metallic solid, and covalent or network solid. So you will get one more question regarding this. According to arrangement of particles and their structure, they are classified as four types. Are you clear? Okay, we shall study one by one. So this molecular solid, again classified into three categories. One is non-polar molecular solid. Non-polar Another one is polar molecular solid, and another one is hydrogen bonded molecular solid. Hydrogen bonded molecular solid. Are you clear? What are the three important types of molecular solid? Those are non-polar molecular solid, polar molecular solid, and hydrogen bonded molecular solid. Okay, you can easily remember this by confirming the example. By confirming the example. See, non-polar, you studied in first PUC in chemical bonding. See, non-polar molecules like helium, neon, argon, krypton, xenon, then again iodine, hydrogen, carbon tetrachloride, carbon dioxide, all these are non-polar molecules. As due to the difference between the similarity, the same electronegativity characteristic, take for example hydrogen, iodine, even carbon tetrachloride, even carbon dioxide, then argon, all these are examples of non-polar molecular solids. Are you clear? See these molecules, hydrogen molecule, iodine. See hydrogen, two atoms. If you go for its electron sharing, they are non-polar molecules. What is the force existing between the non-polar molecules? Very weak force, which is nothing but a dispersion force, which is also called a London force. In first PUC, you studied in states of matter. Okay, that is nothing but non-polar molecular solid. In a non-polar molecular solid, example is hydrogen, iodine, carbon tetrachloride, carbon dioxide, and some of the noble gases like argon. So, what is the force existing in the non-polar molecular solid? The force existing is London force or dispersion force, which is the weakest force, a very weak force. Are you clear? Okay. Then polar molecular solid. Polar molecular solid. Example is even you can take hydrogen HCl, and sulfur dioxide SO2. So these are some of the examples for polar molecular solid. The polar molecular solid, dipole moment exists. Dipole moment. So one atom to another atom, electronegativity difference is there, and that is nothing but a polar molecular solid. If the hydrochloric acid, which is in a liquid state, by varying its temperature, pressure, we can convert that into a solid state. And if it is a solid, if it is converted to a solid, what type of molecular solid it is? It is nothing but a polar molecular solid. What is the force exists between the polar molecular solid? That is nothing but a dipole force, which is more stronger than a dispersion force. Okay. The next, hydrogen bonded molecular solid. See, if the hydrogen forms bonds with more electronegative elements like fluorine, chlorine, and oxygen. And best example is nothing but ice. Best example is nothing but ice. Is nothing but a molecular solid. What is the force there? It is nothing but a hydrogen bond. The element hydrogen forms bonds with other more electronegative elements like fluorine, oxygen, and chlorine. Such type of existing solids are called molecular solids. What are the three important types of molecular solid? Those are non-polar molecular solid, then polar molecular solid, and hydrogen bonded molecular solid. Are you clear? Understood? So one more question you will get. Name the force exists in non-polar molecular solid. So that is nothing but a London force or a weak dispersion force. Then in polar molecular solid, a dipole moment. Due to difference in electronegativity between two atoms, a dipole force exists. And another one is hydrogen bonded molecular solid, which is nothing but example is ice, which is hard. Okay, see all these molecular solids, if you go for its constant particles are nothing but they are molecules. And if you go for electrical conductivity, see all these are non-conductors. Okay, you cannot find electricity, you cannot go for electricity. Then if you go for other characteristics of molecular solid, all molecular solids are soft except ice. So as they are not stable at room temperature, by varying the temperature and pressure, we can convert a gas into a solid, or a liquid into a solid. So therefore, all these are not stable at room temperature. Very important point to remember. See, all molecular solids are not stable at a room temperature. Okay, therefore they are also called soft solid. What about their melting point? Very good. What about their physical state? They are soft. We can compare. You can compare the different analogy of the molecular solid. Easily you can remember. Molecular solids are classified into three types. Those are non-polar molecular solid, then polar molecular solid, and hydrogen bonded molecular solid. Be particular about the example and the force exists between them. In non-polar, we can find weak dispersion force. In polar, we can find dipole-dipole interaction. And in hydrogen bonded, we can find a hydrogen bond, element hydrogen or bonds with more electronegative elements like fluorine, oxygen. Are you clear? Okay. So that is nothing but molecular solid. Okay. What are the important characteristics of molecular solid? They are soft. Their melting point is very less. The force operating between those molecules is also weak force. Okay, so these are the molecular solid. We discussed in detail molecular solid. So we shall continue our discussion on ionic solid. The constant particles are ions. See in ionic solid, the constant particles are ions. Say for example, sodium chloride, potassium chloride. They are stable at room temperature. They are highly stable. What about their melting point? Melting point is more. What about their conductivity? In solid state, they are non-conductors. See, as in molten state or in liquid state, they can conduct. Conductivity is possible in molten or in liquid state. Are you clear? These are the important characteristics of ionic solids. In ionic solids, see you know how ionic solids are formed. What are the characteristics of ionic solids? We studied in chemical bonding in first PhD. Are you clear? See, more electropositive element, alkali, first group and second group elements combines with 17 group elements. They call the stable ionic compounds. They are highly stable because they attain noble gas electronic configuration. Are you clear? Understood? Okay. So that is the ionic solid. In ionic solid, what are the characteristics we have to remember? Ionic solids are stable at room temperature. The constant particles are ions. They are bad conductors in solid state. If they are in molten or in liquid state, ions can conduct electricity. That point you have to remember. What about their melting point? As they are stable, the melting point is more. As compared to molecular solid, their melting point is more because they are stable. Okay, these are the important characteristics we have to remember about the ionic solids. What is the force? It is nothing but a electrostatic force of attraction between the ions. Are you clear? Okay. So here ionic compounds are formed by the transfer of electron. Okay. Next we have to study metallic solid. A very important concept, metallic solid. So you can easily remember metallic solid. See, it is nothing but a metal luster. It is nothing but a metal luster or a metal lattice. See, which comprises by a positive part. The positive ions are delocalized by sea of electron. How to understand a metallic solid? What is the existence of a metal? In any metal lattice, a positive part is delocalized by a sea of electron. Sea of electron. So here, these are nothing but the positive parts. These are nothing but the positive parts, which is called metal kernels. These are called metal kernel. These are called metal kernel, not military lieutenant colonel. Each positive part we will consider as a metal kernel that is surrounded by delocalized free electrons, and those are called mobile electrons. Those are called mobile electrons. As the mobile electrons free to move in the entire lattice, metals are good conductors of heat and electricity. They are malleable, they are ductile. That means they can draw in a thin wire, and also a thin sheet. They are malleable and ductile also. Okay, so how to remember the metallic solid? In the metal lattice, the positive part is, as shown in the diagram, the positive part is surrounded by, delocalized by sea of electron. Particularly, they are called sea of electron, and therefore the electrons are free to move in the entire lattice. So they conduct electricity. Metals are good conductors of heat and electricity. You can easily find the answer. Metals are bright luster. When light falls on a metal surface, the mobile electron starts to and fro oscillation, and it reflects the light. So metals are bright luster. Okay, what are the characteristics of metallic solid? And example: copper, iron, cobalt, all metals. See, you study many metals, you will experience also. Even in day-to-day life, you are going to see many metals. So they are metallic solids. The constrained particles are here metal kernel, which is nothing but the positive part, which is surrounded by delocalized free electron, and those electrons are called mobile electron, not your mobile. Are you clear? It's called mobile. They are free to move in the entire lattice. So therefore, metals are good conductors of heat and electricity. Okay, so resistance is very less. Okay, that is nothing but a metallic solid. What are the important points you have to remember here? Metal kernel, which is nothing but the positive part, and it is surrounded by sea of electron. So metals are malleable and ductile. That means which can be drawn in a form of a thin wire, as well as a thin sheet. And as you hammer it, so one layer slide over. So therefore, it can easily draw in a sheet. And as the mobile electrons are arranged in a well order, so which can be drawn in a wire. So therefore, the metals are malleable and ductile. Bright luster. When light falls on a metal surface, so it oscillates. In to and fro oscillation is possible, and due to it emits the light. It shines. Bright luster means is it shining. Okay, that is nothing but a metallic solid. So last one, which is nothing but a covalent or network solid. In covalent or network solid. So these are also called, these are giant molecules. See silicon carbide, graphite, diamond, and graphite. These are the particular examples for the covalent or network solid. Are clear? So here, what is the binding force? Is nothing but a covalent bond. See, diamond is hardest substance due to tetrahedral arrangement of the carbon atom, which are very strong binding force we can find. Even silicon carbon atom, which is also very hard. Except graphite, all are bad products of the electricity. Diamond is hard. Here, the molecules, the constrained particles, molecules arranged in a definite geometry. See, particularly in the diamond carbon atom is tetrahedral arranged with strong electrostatic force of attraction. Therefore, it is hard. Tetrahedral arrangement, not arrangement. Therefore, force of attraction. Arrangement is like carbon atom has a definite cage-like structure. And graphite is soft in covalent solid. The graphite is good conductor of heat and electricity, which is used as a lubricant also. See, in graphite, the carbon atom is sp2 hybridized, and the fourth electron, one electron, that valency electron is free to move in the entire lattice. And it has a layer structure from one layer to another layer. Weak van der Waals force nearly at 330 picometer distance we can find. So, which is nothing but a graphite is nothing but a pencil day to day in writing which you are going to use. Just to press it, it will break because it has a layer structure, soft weak van der Waals force operating material, and it is good conductor of electricity due to the presence of sp2 hybridization, one of the electron, these unpaired electrons free to move. So therefore, graphite is a good conductor of heat and electricity. Unclear? So this is nothing but covalent or network solid. What about the physical state? No doubt they are hard. In physical nature, they are very hard. What about melting point? So more than 2000 diamond, 3500 degrees centigrade. Very high melting point as compared to ionic solid or metallic solid. Except graphite is the best lubricant. See, in engine oil, everywhere we are going to use graphite. So due to its hexagonal layer arrangement, it's a planar molecule. Hexagonal planar molecule with each carbon atom is sp2 hybridized, and the fourth electron, which is not paired, which is having one unpaired electron, they are free to move. Therefore, it is a good conductor of heat and electricity. Okay, dear students, we studied different types of crystalline solid. You have to apply your knowledge by making difference between all these different types of crystalline solid. Those are, one is molecular solid, ionic solid, metallic solid, and covalent solid. We shall summarize this and we shall find the difference between all types of solids. Say different types of solids, which is nothing but a molecular solid. What are the different types of molecular solid? One is non-polar, and another one is polar molecule, and another one is hydrogen. Are you clear? So this is nothing but a molecular solid. What about the constrained particles here? The molecules. Constrained particles are all molecules. So example, what are the examples here? Molecular solid examples. What about their conductivity? They are non-conductors. Okay, what about melting point? Melting point less. So they are very low melting point. Less low melting point. So example, we can find the example. About physical state, physical state. All these are soft solid. All these are soft solid. Very soft. So they are not stable at room temperature. And example, which is nothing but example, which is nothing but. So these are constituent particles, and here it is conductivity, electrical conductivity, and examples. What are the examples? One carbon tetrachloride, and you can write carbon dioxide. All these are nothing but non-polar molecular solid. Are you clear? See, carbon dioxide, oxygen atom, carbon atom is the center, and one oxygen atom in another side, another atom in another side. The resultant dipole is, that means resultant polarity is zero, therefore it is called a non-polar molecular solid. So this is nothing like carbon dioxide structure. Even though oxygen is more electronegative than carbon, see, as this in one direction, just opposite direction, therefore it is a non-polar molecular solid. Okay, polar molecular solid. So what is the force operating here? It is nothing but a dipole. Whatever is non-polar, it is nothing but a dispersion. Here it is nothing but a hydrogen. Atom hydrogen bonds form with fluorine, oxygen, or chlorine. Are you clear? More electronegative. Just we can summarize the different examples and their characteristics. Easily we can remember. In polar molecular solid, again, whatever they are, non-conductors, whatever melting point, very low. Physical state, they are also very soft. And example for is nothing but HCl molecule and sulfur dioxide, etc. Are you clear? Hydrogen molecule example is ice. So it is little bit hard, not so hard, little bit hard than other solids. Are you clear? See, ice is not stable at room temperature. Are you clear? Okay. So that is about molecular solid. You may get one more question. Give an example for non-polar molecular solid. You have to write that one. Any example you can write. Or particularly they will give an example. You have to write what type of molecular solid. Name the force operating in ionic molecule. You have to write weak dispersion force, or which is also called London force. If you understood the concept, you can easily apply. Are you clear? No need to read again. Concentrate the class. Just go through the notes. You can easily remember. You have to watch live class only. Many students are not watching live class, even though internet accessibility is there. You are lazy. Don't do like that. Every day you have to watch the class. So only morning time from 9 to 1 or 12 o'clock we are going to have some online class. You have to concentrate. And day by day you have to write the notes. Okay. The next is ionic solid. In ionic solid, what are the constituent particles? Those are ions. What about their physical nature? So they are hard, as more harder than molecular solid. They are hard. What about their melting point? Melting point is more than these molecular solid. Are you clear? So those are also, they are non-conductors at solid state. They are conductors in molten and liquid state. Their ions can conduct. You know that is the name of the ionic solid. Example for ionic solid, you can write KCl, NaCl, etc. And then the next you study metallic solid. So points you have to remember. See here, what are the constituent particles? The positive ions with delocalized electrons. That is very important. The positive part of a metal are called metal kernel. They are immersed in a sea of electrons. It is just an appearance. Okay, here you can see. Again, what about they are good conductors of electricity? They are conductors, good conductors. What about melting point? Melting point is more, melting point is more. Then, what about physical state? These are hard, these are hard. So, copper, aluminum, they are good conductors, the resistance is very less. So, some of the points we have to remember about metallic solids. Metals are bright luster. When the light falls on it, the mobile electrons start to oscillate to and fro. And so, therefore, reflection you can find. So, they are bright luster. Metals are malleable and ductile. As mobile electrons are arranged in well order. So, they are drawn in a thin wire. And even they are ductile, which can be drawn in a form of sheet. When it is hammered, the one of the layers slides. It can be easily separated by hammering. So constant all particles, the positive particles and the negative electrons, slide over, which can be cut. So that therefore they are nothing but a malleable and ductile. Okay, and if you go for last one, which is nothing but a covalent or a network solid, correct? Network solid. In covalent and network solid, you can find, say, the constant particles are nothing but the molecules, and they are again bad conductors, and melting point is very high. Physical state, they are hard, no doubt they are hard. And examples, you can silicon carbide, then diamond. And one exception is graphite. See, in covalent or network molecular solid, exceptional is graphite. It is not hard, it is stopped due to weak bond force. Each carbon atom is sp2 hybridized with a planar structure. As it is a weak van der Waals force, it is soft. Presence of one unpaired electron is a good conductor. Are you clear? Very easily we can remember. And these network or covalent solid, very high melting point. For example, silicon carbide diamond. So, this completes our study of different crystalline solids. What are the four important types of crystalline solid? Molecular solid, ionic solid, metallic solid, and covalent solid. Are you clear? Okay. So, what are the other characteristics of each solid? We can easily summarize. So, you will get simple 2 or 3 marks question or 1 mark question can be asked even for CE. Okay, dear students, we shall continue our discussion tomorrow on a crystal lattice, how the solids, arrangement of particles in a solid exists. Okay, in today's class, we discussed about the basic introduction about the solids, the crystalline and amorphous solid. What do you mean by anisotropy and isotropy? Crystalline solids forms anisotropy and amorphous solid forms isotropy. It is nothing but a physical property due to the arrangement of the particles. Understood? Okay. Okay, dear students, I am going to end the class. You have to watch the live class only, all the subject, and some of the questions can be discussed. And I think all you are completed P block element notes, and shortly our department will give the new syllabus, some of the cut down syllabus shortly are going to get it. And we don't know when this COVID-19 issue ends, even though we are going to keep touch with you on online class. So we are very happy to deliver online class as our students are lively watching the class. All the students just you have to subscribe the channel. Many students are subscribed, but some of the students still you have to subscribe. Okay, thank you.